Hello everyone, welcome to a new episode of Golang Cafe. Today we are going to talk about debugging with Go. We are going to specifically talk about Delve, which is one of the most popular debugging libraries for Go, and it is also recognized as a feature-rich debugging library and tool by the Go team. If you check the GDB page, which is the debugger developed by the Go team, you will see that Delve is recognized as a feature-rich debugger. I don't usually cover specific libraries in Go in this channel, and the reason why is because I want this channel to be full of evergreen content. I want to make sure that the content that is covered here is going to be the same or at least still relevant in a few years. So I'm pretty sure that Delve is a pretty solid library for debugging, and we're going to see today how we can use it. You may already have used it if you have worked with Visual Studio Code, which integrates well with Delve as well, and other IDEs. Today we're going to see the command line version of Delve, and it's going to be very powerful because it allows us to control in very detail the whole functionality of the Delve debugger. The first step is to install the debugger itself. I will leave a link in the description below for further details on the nuances of installation. I've already installed Delve, and I will also now with you show how you can install. It's just one simple command. It's just go get. So the first thing is go get github.com go-delve delve cmd dlv. And this is the binary that's going to be installed in your machine, and that's what you're going to use. In order for the installation to go successfully, you need to be you need to have the go bin environment variable set and the path set properly. Those are all things that you should already have if you have a working Go installation. In my case, we can see that the debugger is already installed in version 1.5.1, so we can just carry on. There are some nuances around the Xcode developer tools if you're on Mac, and you also need to make sure that if you are in a package, in a directory where you have the go.mod, you need to run this command outside the directory, because that will add Delve as a dependency of your project, which is not necessarily something that you want. So we have our project here. It's not a go.mod project, it's just a bare project with a main.go file, and you have a cmd with a bunch of files here, and the Delve debugger allows us to see a bunch of commands just by typing dlv help. As you can see, there's a bunch of commands. If you want to figure out whether or not your version is working, your installation is working, you can just type dlv version, which shows you the version that is installed at the moment. So again, going into the help tool, you can see that we have a bunch of commands. Today we are going to see mostly the debug command. There is also other ones which we can cover in a different episode. Although we know that the debug and exec are two commands of the same breed, because they are all about running a debugger on top of a set of files. The debug one also compiles the files from source. The exec will expect to have a compiled binary, so they are all the same. You have the help, the run is an alias to debug, and then you have some other commands which we are not going to see today. Something also interesting to know before we go ahead is that you can also run the debugger on the Go tests, so you don't necessarily need to have a main package to run the debugger. Today we are going to run the debugger with main packages. So when you run the debugger, you want to run it starting from a main package, and here, as I said, we have three main packages. And the reason why we have three main packages is because I wanted to show you that the Delve debugger can work with very big projects. I don't have a very big project today, but I have a structure that resembles the one of a big project. You may have different command lines, different binaries, different main packages, and you may want to test each of that one independently. And you can do so with Delve. Obviously, you can run only one at a time. Let's just check what the contents are. So in the first one, you see that it's just a hello, and the second one is similar with LOB, so it's coming from the second one. The main file is a Fibonacci implementation. You see here, the Fibonacci is a set of numbers, there's a sequence. Then there is a Fibonacci implementation, which is using also a map for allowing us to run the implementation quicker. which is a memoization technique for running the Fibonacci. We are trying to just explore the functionality of Delve today. So the first command that we're going to use, we said that we can run debug, which is the command that we saw in the help tool. And debug can be followed by a main package, so you can either say cmda main.go, and that will work, or you can also say, we can exit now, you can also say b.go, or you can also say main.go, and that will also work. So you just need to pass the main package that you want to debug, or you can also say debug, and that will pick up the package from the current directory. Now it's not working because there is no go modules in this project specifically. So we'll just do debug main.go. The first command that I want to explore in this section is the command, the list command. You can see a set of commands just by typing help again. And you will notice as slightly different from the previous help command is that the previous one is kind of if it's a server, and this one is a client that is talking to the Delve server, which we just started using the debug command. So this one is used to navigate the debugger through the program and adding breakpoints and showing code and doing some data manipulation and all things that we will see. The first command that I want to show you and that I want you to see is the list command. The list command allows us to basically explore the source code of a binary that is attached to our debugging session by just typing the path of that file and the line where we want to show the code. So we'll see here that we have the actual contents of that file, and it's very easy for us to see the contents of that with the list command. This can be useful if you want to orientate yourself inside the debugger itself without having to go and switch back to the editor and do back and forth with the debugger. This specifically applies if you're using the debugger from a command line. So this is the list one, which is under the other commands section. There is also a bunch of other commands which are not really interesting for us today. Another section which is useful is the breakpoints section. So you may know that with debugging, the whole bread and butter of debugging is working with breakpoints. The breakpoints are basically some pins that you can add in your code, and the debugger will run through the code and will stop at those pins that you set, and those pins are just breakpoints. You can set the breakpoints using the command line here, but if you work with other IDEs or with other editors, the breakpoints are set just by going into the editor and manually clicking through the UI and adding the breakpoint on that line. Here is a bit more fiddly if you want, but it's also very precise, and it is also very clear where your breakpoints are. To add a new breakpoint, you can just type the keyword break, and then you can type the path of the file and the line of the file where you want the breakpoint to be added. In our case, it's main.go line 10. And you will see the breakpoint 1 has been set for main.go line 10. If we run the list main.go line 10, we see, okay, where is our breakpoint? Exactly is at this famt println, so the breakpoint will exactly be set in that location. There are two ways that you can specify a location for a breakpoint when you create a breakpoint. One we already seen it, which is break, and then you say main.go, which is file path, and then you say colon, and then you say the line number. Another way is to specify the package name, and then you specify the function under the package name, and that will set the breakpoint exactly at that function. So if we say break main, which is the package main, then we say fib, which is the function. You see here line 14 is a fib function. Well, that will create a breakpoint in the Fibonacci function, in the entry of that function. That's also a way that you can specify a line in your file. Now we can see all the breakpoints by using breakpoints command. This will show us the list of all available breakpoints currently set for our debugger. We'll see that we have a couple of breakpoints 1 and 2 in line 10 and line 14, which are the ones that we set up. And we also have a couple of other breakpoints which we didn't really set up, but those are breakpoints specifically to Delve that are set up at panic.go line 1162 and 1189 for panic.go. Those are set up for us to make sure that when the program panics or when the program exits with a fatal error, then we have a breakpoint before the program terminates. And the reason why we have that is because then we can analyze the status of the variables, and we can figure out why the program has failed or panicked. And that's quite handy, because otherwise you would have to do it yourself. Each time the program panics or fails, then you would have to figure out where it panics and why, and it would be quite frustrating. But Delve does it for us, and it's quite useful. So you will always have 2 breakpoints by default, and then you have all your other breakpoints. If you want to remove a specific breakpoint, you can just specify the name. So you can say clear 2, for example. This will remove the breakpoint, or you can do clear all, and this will remove all your manually added breakpoints. Now again, you see now the breakpoint 2 has been removed. So we have seen how to add a breakpoint, how to list the breakpoints, how to remove breakpoints. We have seen how to look into the code directly from the debugger. And we already got into quite far away in the usage. And then there is the navigation. The navigation is the way that you navigate using the debugger. So you can navigate using the continue command, which is what you may already have used when you work with other debuggers. So when you say you hit on the UI, you hit continue, and that will continue until the next breakpoint, or if there is no breakpoint, it will continue until the program terminates. And that's quite handy if you want to quickly jump into a location where you had your breakpoint. Let's say you have a very big project and there is a lot of files and there is a lot of function calls. You don't want to go line by line until you reach your desired location. You just want to directly go straight into your breakpoint location. At that point, you can just say continue, and that will bring you directly to that location. And we'll stop at the breakpoint location. Then you have the next command, which is what you usually use when you are in the situation of investigating any issues, and that will allow you to step to the next line, the source line. So that will allow us to go line by line in your code, and then eventually see all the variables contents each time you advance with the next. We'll see how we see the variable code in a moment. There is a specific command for that. But the next is what you're going to use to advance just one line at a time if you want to. And then there are 2 others that I think are useful. There is a bunch of them here, but I think if there is a takeaway from this is that you need to take away 4 commands. The continue, which you have seen, the next, which you have seen, step in and step out. The step in is a step, it's called step in Delve. I call it step in because in other IDEs or generally with debuggers you will see step in and step out. And the step allows us to go inside a function call. So if you have a set of lines and one of those lines has a function call, step allows us to go inside the function call, inside the function content, and again we go line by line inside the function. If we were to call next instead, the function would be called, invoked, and run automatically, quickly, at once, and the result returned all at once. So we don't see what's happening inside the function. If we want to see what's happening inside the function, we use the step in or step in Delve. If at some point we are inside the function, but we already investigated, or we want to go back to the caller, we can call step out, and that will quickly execute all the function and returns back into the caller. So those are step and step out are functions that commands that you can use to navigate quickly between functions, function calls. So from the running the program, there is 4 main commands that you can take away. The continue up until the next breakpoint, the next, just go one line at a time, step and step out, which allows us to go inside or outside a function. And then there is one which is restart, which you can use if the program terminates and you don't want to start from scratch debugging. You want to exit your debugger and type again delve debug main.go and then set all your breakpoints and all of that. You don't want to do that. You can just type restart, and that will restart the program from scratch within the same debugging session and keeping all the breakpoints. That's quite handy if you're running a long debugging session. So you have 4 plus 1 main commands that you want to remember. We have seen already the breakpoints. Again, here is mainly 4, which is other breakpoint list, clear and clear all. And obviously the other ones you can explore. You can also let me know in the comments below if you want me to cover other commands. But I think those are the most important ones if you want to cut it short. And then there is the viewing the variable contents. So here you can have three main takeaways. You have the print one, which allows us to view variable contents and expression values variables using the print. You can print value a variable when you are in a specific line. You can use the locals if you want to quickly see all the local variables in that context. And you can also use a set, which allows us to change the contents of a specific variable. You also have other ones, but I think if you want to quickly start debugging and start learning, I think those are the ones that you definitely can use, and they allow you to carry 80-90% of the work automatically. You don't certainly need more than that if you want to go ahead. In another episode, we will cover also working debugging coroutines, which is something I'm not gonna see today. But those are the main ones. So say that, let's try to run a debugging session. So we have the breakpoint 1 and lane main.go and line 10. We're going to do list main.go just to refresh our mind, line 10, what's going to happen. So we have font, print, and len. Let's say that I also want to breakpoint a line 9, break main.go line 9. I want to remove the breakpoint at line 10. I just want line 9, and I want to go line by line after that. So breakpoints. You have 1 and 3. I want to remove 1, clear 1. Okay. So now I can just type continue, and that will execute the program up until the next breakpoint, which is line 9. I can now use the print, which is what is going to be used for printing values. So print n is 5, print x is not yet defined because we yet have to calculate that value. Now if we type step, that will go inside the Fibonacci function, and now the Fibonacci function we can again we can print n. You see we are at n5, we go next, 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 and we see that now here we have two other function calls. So if now we can do step, and that will again jump into the function call in that case. Print n. So now we are calculating 5 minus 2, which is 3. So it's next, 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 next. I can print the value of the map, which is empty at this point. I want to also step in, so this one should be 1, print n is 1, because 3 minus 2 is 1. So apparently the way that the compiler invokes the function is right to left. So we first, because we see that sorry, it's left to right. We see that the first function to be invoked is Fibonacci n minus 2, which is 5 minus 2 is 3, is the first one to be invoked. Then from 3 we have 3 minus 2, Fibonacci of 3 minus 2, which is 1. And we also can see the stack. We also can see, this is another command, we can also see how many function calls we have done so far, and how deep we are into the stack. So we see from the main.go we call Fibonacci, the Fibonacci called another Fibonacci, the Fibonacci called another Fibonacci, and so on and so forth. That's what happens usually with the Fibonacci function, that you have a very long stack. But let's say that I want to go back into main now. I investigated my problem, I just want to go back into main. I do step out, I do stack, let's see, we have one less Fibonacci, step out again, stack, I have one less Fibonacci, step out, and now we are back in main. Now let's print the value of x, it's still not there because we need to return the value. Next, print the value of x, which is 5, obviously Fibonacci at sequence 5 is still 5, it's a bit deceptive, but that's how the Fibonacci value is. So now let's again, we can also check how the println work, and here you can see that you can also check how the println works. And if you see, I'm just sending return, and that will execute the previous command. So we're doing step in, step in. Oh, now we are inside the new printer. All the internals of fprintln. Print p. Let's see what happens. Obviously next, print p. You see all the buffer. So this is not something that's interesting to us. It's all standard library stuff. Step out, and next. and exactly. So let's see if we got the value that we wanted to print. Next. Fibonacci 1, so we'll see here the 1 Fibonacci 1 has been printed. We might have missed the 5 one somewhere. 5 Fibonacci 5 as well. So you can navigate using next and continue. So we can just, again, run continue, clear all, and continue. Now this terminates the program. So what about now if I want to restart the program? I can restart the program. I can see all the breakpoints. There is no breakpoints. I can break line 10. And again, what we're gonna see now is the same as before. So it's line list main.go, line 10, as you can see here. Continue. And then we have n, which is 5, and then here we go again. So it's quite easy to navigate the program in this case because we have all the commands that we need. We have the possibility to use the step in function to go inside function, step out of function. So if you want to quickly go out of a function, so we can set the breakpoints where we want. We can also print the values of variables. We can, if you want. I don't think it's something useful, at least in this scenario, but in general I never actually, when debugging, I never actually changed variable content because it's usually enough for me to see what's the behavioral algorithm or a program if I see step by step the value of all the variables. And that's something you can do using locals. So with locals you see all the variable contents, as you see here. Locals again, you see now it's just n, locals n1 x1, and so on and so forth. And locals 98. So now if we print the value of our map, it contains all the Fibonacci from 0 to 98, from 1 to 98. That's also something we can expect using the print command. I think that was pretty much everything. Using the Delve debugger is quite easy if you know all the different commands that they can offer. And I hope you liked the video, and let me know if you have any questions in the comments below. Thanks.